So here are the worked examples for solving right triangles. So we're given B is 45 and C is 5. And so if this is 45, this B is 45, then without even doing a lot of work, we know that angle A will be 45 degrees, right? So we're looking for A, that is 45 degrees. The next thing we need to know is A and B. Now, because we know that this is a 45, 45, 90, there's a special property for that. So we could use that instead of using the other thing we did earlier. So if we know that C is 5, in order to get to the shorter leg A, we need to take 5 and divide it by 2. Of course, we need to rationalize the denominator, so multiply by root 2 over 2. So the answer is 5 root 2 over 2. And that is true for both A and B. Okay, so I'm going to spread that out a little bit. So it's 5 root 2 over 2, and then B is also the same thing. Now, if you wanted to go ahead and solve it how we did it earlier, that is totally fine. So if we know that B is 45 and we want to know A, and we know C, we could say that, let's say, cosine of 45 degrees equals A over 5. Then if you remember earlier, cosine of 45 degrees, that is root 2 over 2. That equals A over 5, and then you multiply by 5. So you see that it's the same exact answer, 5 root 2 over 2. Then you could plug it in your calculator if you want to, but usually I like to leave it in square root. But if you did plug it in, that would be 3.54. Okay, so let's try the next example, 7. So I drew my little triangle first, and so we labeled what we know. We know A is 32 degrees, and lowercase b is 10. So we need to find out what angle B is. So again, to find angle B, you just take, so angle B, or just B, you take 90 degrees minus 32 degrees, and so angle B would equal 58 degrees. Okay, so that is B. Now we need to find out what A is and also what C is. So given 32 degrees, we know B is 10, the adjacent, and then we want to find out A. So let's write a trig ratio for that. We could use tangent of 32 degrees equals opposite A over 10. Then you multiply by 10 to both sides, so you get A equals 10 tangent of 32 degrees. So we don't know that one, so you have to plug it into your calculator. And once you figure that out, once you type it in, then you should get 6.25. A is approximately 6.25. So now let's figure out C. So that's the hypotenuse. We know adjacent is 10. So adjacent, so let's think about cosine of 32 degrees, and that equals adjacent is 10 over C. Now, what I want to do with that is I want the C on top, so let's do the reciprocal. Now, I could use secant, but let's go ahead and just do 1 over cosine of 32 degrees equals the reciprocal C over 10. Then you multiply by 10 to both sides. Remember, that just goes in the numerator. So we're really evaluating C equals 10 over cosine of 32 degrees. Then you go ahead and plug it in your calculator, and once you do that, C is approximately 11.79. 11.79. Okay, so let's go ahead and try the next example here. We have A at 71 degrees and C at 20. So let me draw my picture first. Okay, so we know that A is 71 degrees, so we need to find out what angle B is. So what is B? So in order to do that, we just do 90 minus 70, 90 degrees minus 71 degrees. So B is 19 degrees. Then we need to find A and B. So A, that is opposite of 71 over the hypotenuse. So we have sine of 71 degrees equals A over 20. Now, when you're doing these problems, please use what you're given instead of just changing it around, just so you can get some practice with using the different trig ratios, okay? So what I mean is don't use, sine of 19 instead. So just keep on using the 71 in what you have. So in order to solve for this, you multiply by 20 to both sides, and then once you plug that in the calculator, so 20 times sine of 71 degrees, A is approximately 18.91. Then let's try to solve for B. So we need to solve for B. So that is adjacent. We need to know adjacent over hypotenuse. So that's cosine of 71 degrees equals adjacent B over 20. Then you multiply by 20 to both sides, and then you plug it in your calculator. So B equals 20 times cosine of 71 degrees. And so that will be approximately 6.51. Okay, so that is A. Here is B, and then of course this is our angle B. Now the last one, we know that B is 60 degrees and A is 7. So if we draw our triangle, this is A, C, and B. So B is 60 degrees, and we know that A equals 7. So we need to try to find B, and we need to try to find C, and angle A. So A, if this is 60, 90, then we know that is already 30 degrees. 90 minus 60 is 30 degrees. Now, if you remember, we could just use a special properties. So if A is 7, then lowercase c, that is the hypotenuse, 7 times 2, that is 14. Then if you try to find the long leg, B, you just take 7 and multiply it by root 3. Okay, and so that's a fast way to do that. If it's a 30, 60, 90, you could just use those properties. But if you want to practice, we can go ahead and figure this out using what we have. So we have 60 degrees, and we know A is 7. So we have a cosine of 60 degrees equals 7 over C. And so what we want is we actually want the C on top. So let's do 1 over cosine of 60 degrees equals C over 7. And cosine of 60 degrees, if you look at your chart, cosine of 60 degrees is 1/2. So this is 1 over 1/2 equals C over 7. Now, if you remember, this is a complex fraction. 1 divided by a half, that's really 1 times 2, or just 2. So this side simplifies to just 2 equals C over 7. And then you multiply by 7, right, to simplify it. So C equals 14, and that's what we got above. Now, if we try the next one, we want to figure out what B is. We can do tangent, right? Tangent of 60 degrees equals B over 7. So looking at your chart from earlier, tangent of 60 degrees is square root of 3. So square root of 3 is B over 7. So then you multiply by 7, and look, B equals 7 square root of 3. Okay, so I hope this helps out. And go and watch the next video to do the word problems.